Here we will see how to work with the principle of the angle of depression. It's useful for when we want to properly construct triangles to find information about them. So here is an example. Sally is drilling a well to an oil deposit that is 2,300 meters below the ground. And also, the ground has a lake on top of that, which is 150 meters deep. There's also another point, that the well must be drilled 1,000 meters from the point of where we are drilling this, and it has to be at an angle. So I'll show you the diagram of what that will look like. We are going to have our oil deposit over here, and there is a lake on top of the ground. So if we're going to calculate from the ground, well, yes, this will be our 2,300 meters. But then with the lake on top, we're also going to have this part, which is 150 meters. The other thing is that we have to make it 1,000 meters, and it actually doesn't matter in which direction, but 1,000 meters away from this point where we are drilling, it's going to have to go on an angle. So this is going to be our angle we want to find. The angle of depression is the angle between the horizontal line and the line of sight. So if this is the horizontal and then the line of sight, we're looking down in order to get to this oil deposit. That's where we want to get to, and we're looking from a horizontal. So this is actually the angle of depression we are looking for. To find it, we can draw the triangle now that we understand the situation in order to actually solve it. So here's a little bit of a tricky part where you have to remember that for the full triangle, we need to account for the amount underground and the amount of the lake above the ground that we're drilling, because we are standing on, say, some ground over here, and then it goes down into this lake. Well, we are going to be drilling from the top of the lake, relative to the top of the lake. So now that the triangle makes more sense and we know that we are looking for this angle, which is the angle of depression, and then we have 1,000 over here. This is 90 degrees down, and then over here we have 2,450 because we added 150 plus 2,300, and then we can just use the trigonometric ratios in order to find this missing angle. So let's write out SOHCAHTOA. And it turns out that relative to this angle, we have an opposite and we also have an adjacent, which means that we can use tan. So tan of theta is equal to the opposite over the adjacent. And then to find the actual angle, we're going to get the inverse. And that gives us about 68 degrees. And that means that the drilling should be done at 68 degrees, including all the 1,000 meters away, and that is how far it's going to be drilling down.